So I wanted to spend some time on elastic collisions because they're the only interaction where the kinetic energy in the system is constant. And so what that tells us is this is the only situation where we can use conservation of momentum and conservation of, in this case, kinetic energy. So we can start out with these two equations for, let's say, a two-mass system. And the conservation of energy equation, or at least kinetic energy equation, would look something like this for a two-object system. Probably going to run out of room soon. We can kind of simplify this, and all the halves will cancel. Basically, through some clever algebraic manipulation, we could solve one for the mass of one or the mass of two, and substitute that into the other equation. And basically, what we get is the relative velocity of the two objects in the beginning will be reversed. So the relative velocity of the two masses, so one with respect to the other, will actually end up reversing. So the magnitude will be the same, but it'll now be the approaching at that speed if it was leaving at that speed. And this is strictly for any two objects colliding elastically. It doesn't matter what the masses are. They don't have to be equal. If they are equal, we'll get a complete momentum transfer. So you might see this in like a billiard ball game, like 9-ball, 8-ball, cutthroat, anything like that, where you hit the cue ball at one of the other ones. I think 9's got the stripe. Anyway, when it collides, if the collision is elastic, the cue ball will stop, and the 9-ball will get rolling. This isn't going to happen every single time because the balls are rolling, so they also have an angular momentum, and that can come into play too. But if it's perfectly elastic, we'll get a complete momentum transfer. So this one will leave at the speed that the cue ball was approaching. But if they're not the same mass, then obviously, because they experience the same impulse, the same force, the one with more mass will have a smaller change in velocity. The one with a small mass will have a greater change in velocity. But this will still hold true.